Hello. Today we're going to review all of the different methods of factoring when they're all put together. So the first thing to always look for is a GCF in the problem. No matter how many terms it has, always ask yourself the question, does it have a GCF? If it does, you would factor out the greatest common factor and you'd leave it out in front. And then you ask yourself, can I keep on going in any other part? So let's go ahead and take a look at some examples here. So let's say we already took out the GCF and you have something that is 4 terms left. You can see the instructions on the left. We want to split the expression into 2 equal groups. So you're going to chop it down the middle. In each group, you want to identify what's the greatest common factor here. So these first 2 terms here have an x squared in common. So what we're going to do is we're going to divide out the x squared of each of those, and we're going to put that GCF out in front. We would be left with x plus 5. For the next 2 terms here, we have 2 and 10. Looking at those numbers, they have a GCF of 2, but my leading term is negative, so what I'm going to do is I'm going to factor out that negative sign as well. So you divide everything by -2, and when you do that, you're going to be left with x plus 5. Notice the negative divided by the negative gave us that positive. Now this has to be the case. You have 2 parentheses now that are identical. That's going to be one of your factors. And then the coefficients, when you put those together, that's going to be your other factor. So you get x plus 5 and x squared minus 2. Now you can always check your answer by distributing if you would like. Then sometimes we might have something that's only 3 terms left behind. So if there's 3 terms, you have to identify, looking at the problem, if A is 1, meaning there's nothing out in front here, there's technically a 1 there, then you can use our shortcut. Okay, that's what we kind of call this one. The shortcut was the number pairs. So we're going to find the factors that multiply to get A times C and yet add to get B. So looking at this, we are looking for what multiplies to get -3, but adds to get 2. When you find those factors, then what we're going to do is we're going to write them out as our factors using a shortcut. So looking at this, the numbers that are going to work, they're going to have to be 3 times 1 because nothing else multiplies to get 3. And because it has to be negative, we're going to make the 1 negative to make that other part, the adding part, work out. Once we find these factors, here's our shortcut method. We can go ahead and just write out our parentheses. Our first term is going to be x. We're going to do +3 in one of them and -1 in the other. This is our factored form. And this works because let's go ahead and check this one. If we were to multiply, we'd get x squared minus x plus 3x minus 3. And if we were to combine those, we'd get x squared plus 2x minus 3. That's exactly what we started with. So when a equals 1, we have this huge shortcut we can do. But when we have 3 terms left, we don't always have a equal to 1. Most of the time that we have 3 terms, there's a number out in front. So when that's the case, we're going to start off the same way. We're looking for what multiplies to get A times C, but at the same time adds to get B. So off to the side here, we're going to write multiply, and we're doing 8 times -3, which is -24. The add portion is in the middle here. We're looking for what adds to get 10. So you think through your number pairs, and sometimes it's kind of harder to think through your number pairs, so you can make a list. It's 24 times 1. If we divide by 2, we would get 12. If we divide by 3, we would get 8. 24 divided by 4 is 6. And then after that, it's repeats. So there's a couple potential ones. We have 2 and 12. We could potentially get 10 out of, and 4 and 6. So you have to be careful here because we have to multiply to get the -24, but add to get 10. Which means this is going to rule out 4 and 6. So our option here is 2 and 12, and this is going to work if we have a positive 12 and a negative 2. Now we have to do this next part. We cannot just jump to our answers because we have an a value. So we bring down our ax squared term, we bring down our c term, and we split up the bx. So we have 8x squared plus 12x minus 2x minus 3. Then this looks like the problem we just did with 4 terms. So we're going to chop this in half and figure out what they have in common. So our first two have a 4x in common. So we can divide out 4x. We'd be left with 2x plus 3. The next two don't have anything in common, so we're going to factor out a 1, although my leading term is negative, so I'm going to go ahead and factor out a negative 1. Negative 2x divided by negative 1 becomes a positive 2x, and negative 3 divided by negative 1 becomes a positive 3. Now my parentheses are the same, so I get 2x plus 3, and then 4x minus 1. Again, you can feel free to check your answer by distributing this. You should end up with exactly what you started with. So we have talked about 4 terms, you split in half, you do your grouping. With 3 terms, you can use the shortcut of the number pairs or split middle term. But you don't always have 4 or 3 terms. Sometimes you have 2 terms. So if there's 2 terms, you want to look and see if it's the difference of 2 squares. So for this one, you're looking to see if it's a perfect square for your first one and a perfect square for your second one, separated by a minus sign. If that is the case, what you can do is you can take the square root of the first term and the square root of the last term. That's going to be your numbers in each of these. And you write one with a plus and one with a minus. So for instance, here, 25x squared. This would be equivalent to 5x being squared. So I took the square root of 25 and the square root of x squared. For the next one, 9y squared, the square root of 9 is 3, and y squared would be y. So 5x is being squared and 3y is being squared, and they're separated with a minus sign, which means this is the difference of 2 squares. So you're going to plop down your parentheses. 5x is your first term, 3y is your last term, and one of these should have a plus, one of these should have a minus. This would be your factored form. And let's make a note here. If you have something that's perfect squares and it's a plus sign, that is going to be prime. That is not factorable. Okay? So zooming out to look at the large scale things, step number 1 always remains the same. You look for a GCF. Then you figure out how many terms does it have, and you factor it based off of the number of terms. So the rest of this then is practice problems that you can go ahead and try. I do want to do one problem all together. Let's go to number 17. We'll do one more together. And this is putting everything together. So for all of these on this page, you want to factor out the GCF and then keep going. So there are examples here, both where when you factor out the GCF, for one example, it is a equals 1. So you can use your shortcut method. For the next one, this is the difference of 2 squares. So you can see the different methods of factoring here. So let's try one of these together. So for number 17, all of these have a GCF. Let's look at the numbers first. So we have 10, 15, and 5. 5 goes into all of those. Then look at your x's. We have 4, 3, and 2 x's. So the ones they have in common are 2 of them. So what we're going to do is we're going to put the GCF out in front, and we're going to divide each term by 5x squared. We would be left with a 2x squared for my first term, minus 3x, and then plus 1. So we have factored out our GCF and we'd be tempted to say that we are done, but I'm going to zoom in a little bit here. Looking at this remaining polynomial, we can factor this further. So we are going to go ahead and identify A is 2, so we have to use split middle term. So what we're going to do is we are going to multiply A times C. We are looking for what multiplies to get 2 times 1, and yet adds to get B, which in this case is -3. So when you're thinking of your numbers, what multiplies to get 2, it has to be 1 and 2. And for the adding part, if they're both negative, that would give us -3, and it would still multiply to get a +2. So now what we're going to do is we're going to take that GCF, and we're just going to draw an arrow down, and we're going to rewrite the GCF of 5x squared at the bottom so that we don't have to think about it anymore. Then we can take this trinomial here, and we can write 2x squared plus 1. And then in the middle, we can break this up to be -1x and -2x from the numbers we got. Now we can chop this in half. The first two terms have an x in common. So we'd be left with 2x minus 1. The next two terms don't have anything in common, but we are going to factor out a -1. So we would be left with 2x minus 1. And now the 2x minus 1 is the common factor, so we're going to factor that out and write it once. And our other factor is going to be x minus 1. This would be our final factored answer if we could take out a GCF and then do split middle term after that. So thank you very much for listening. I hope this helped.